So I'm just going to give like a brief kind of, 5-minute overview about kind of the graph and why we're building this protocol. And then I'm going to kick it over to Jorge, who's one of our engineers, who's going to give, the actual workshop. So I'm going to kick it over to Jorge, who's one of our engineers, who's going to walk through how to build a subgraph and deploy it to the hosted service, just to kickstart anybody who hasn't gone through that process yet. So I assume that most people kind of know generally what the graph is. It's an indexing and query protocol for Web3. And just going to give a little bit of background and kind of motivation for why we're doing what we're doing. I think that Ethereum and blockchains and all of this activity that's happening on Web3 is really exciting. And I think that like this is going to be the next platform, right? That basically we've seen like a whole wave of startups get built. First it was just like web applications and kind of Web 2, and then like mobile kind of just kicked off of that. And, we had this like explosion of apps, and it feels to me like that wave is kind of now like trending down, where essentially like, the big mega companies, got really big, and then they started sucking a lot of the air out of the room. There were so many different startups, and it became harder and harder to kind of differentiate. And, you kind of have this situation where, if I use some random app, I'm making an investment in that application. And I kind of have to hope that that app succeeds long term. Otherwise, I've wasted all of my time and effort that I put into that application. And I think that that provides, a whole lot of friction in terms of like which apps people are willing to use. And I think that like, there's, so many different factors here that basically creates this kind of like concentration in terms of the apps that we all use. And so I'm really excited about Web3 as being a new platform where, developers all over the world can collaborate, and, it just kind of changes how software can be built and operated and funded, and, changes the relationship between like the users and the applications, where essentially, users own their personal data. And so there's like, privacy component, which I think is nice. That data is portable. And so I can use different applications, seamlessly switch between them, and my data just follows me. And there's all of this like global public data that any application can just use. And so instead of living in a world where every startup is basically duplicating all of the same work, setting up your own infrastructure, setting up your own database, building up your own internal, networks and network effects. You can just plug into this kind of global infrastructure, build an application much faster, deploy it out there, and have it just run. And I think that's kind of the future that we're building here with Web3. I think in 2017 we kind of had this explosion of interest, and a lot of that was correlated to prices, and everyone had these crazy ideas for like all of these things that you could do with blockchain. And I think the hype kind of subsided also with the pricing, but I think a lot of those ideas were actually correct, and we're just a little too early. And so now we're kind of in this place where we're smacked with the reality that like you actually can't necessarily build these applications, and like the pieces aren't quite in place yet. And then you also have just the fact that like just because you're building on Web3, it doesn't insulate you from the realities that like people are only going to use software if it solves a problem that they have, right? And so it's this kind of thing where we need to have entrepreneurs that are finding like real problems that exist in the market. We need to have infrastructure that allows you to build great applications on top of Web3. And I think that when we have the intersection of both of those, where just Web3 becomes the best tool for the job, and we have this infrastructure where it's much easier to build these applications, and you can deploy it, and you have like this kind of global network effect across developers that are all sharing a lot more of this infrastructure. That's going to be the way things go. So with the graph, we're solving an immediate problem, and then we're kind of setting up to be part of this like infrastructure layer. So the immediate problem that we solve is that as soon as you try to build an application on top of a blockchain like Ethereum, you quickly realize that you can't actually get the data that you need directly from like an Ethereum node. And that's because any like usable application requires you to essentially filter, sort, paginate. You want to get some subset of the data onto the screen, and the Ethereum nodes just don't maintain the indexes that you would need to be able to query them directly. And so what every team in the space has had to do is build some kind of proprietary indexing server where now you have to trust that they're doing those computations correctly. You have to trust that they're getting you the data back correctly. You have to trust that they're going to continue to be around and operate those servers. Otherwise, your app breaks, and that really defeats the purpose, I think, of the infrastructure that we're trying to build here. So the graph is a solution to that problem. We've got a standardized way for defining how to index data, so that you can query it directly from your from your applications. We launched our standalone graph node implementation July of last year. We've had a bunch of people building on it, and we've been working really closely with projects to add features and make this a really robust and full-featured query layer. And then January this year, we launched our hosted service, and now we're working with a lot of different Ethereum projects to get them onboarded. And the goal is to have all of this data indexed and available on the graph, so that it becomes easier and easier to build applications on top of Web3 because all of this data is available. And so we've got this hosted service out today, and then we're working to make this a fully decentralized protocol, which is going to happen over a series of milestones as we basically maintain this kind of quality bar of having infrastructure that's fast and reliable, and then decentralizing pieces of it over time. So that's a little overview about the graph. Now I know that you all have probably ideas in mind of stuff that you want to build, and I'm gonna kick it over to Jorge to do a quick walkthrough of how to build and deploy your first subgraph.
Hey, Yaniv, thanks. Actually, Jannis is going to take over the example deployment here.
Okay, great.
Hello. Hello, everyone. Cool, yeah, I'll share my screen and I'll walk you through. So there's a couple of ways you can create a new subgraph. Shall we start with the Explorer, or was the idea to go straight, start straight with Graph CLI?
You can do it in whatever order. We could start with the CLI.
Okay, so yeah, I guess it does make sense to start with the Explorer briefly. So before you can deploy a subgraph to the hosted service, you'd have to create it first, for which you go to your dashboard, click on Add Subgraph, type in your subgraph name and some details, and eventually it will show up on your dashboard, and then you can, at that point, you can deploy to the subgraph.
We just added some validation to try to point people towards making these nice kind of title case names, because we think things just look nicer when they're written for humans.
Yeah, and you also get a nice preview on the right-hand side. If you type in the description, it shows up straight away, and you can replace the image anytime, which wasn't possible before. So once you've created a subgraph, you'll have to configure your graph, your local graph CLI to authenticate authenticate yourself with the hosted service. So you'll go to your dashboard, copy the access token, then run graph auth. I think it's the graph.com deploy. Type in the access token, and that will authenticate you whenever you run Graph CLI against the hosted service for deploying subgraphs. And then you're going to do, let me quickly move that out of the way. So then you have different options of creating a subgraph and then deploy them to the hosted service. The first way is to run, generally all starts with graph init, where you can create a subgraph from an example subgraph that we've prepared and that we maintain and keep up to date. You can just call graph init dash from example, and you give it a subgraph name. If you run help, you'll get some information. You'll see the two modes that it can run in. We're going to try the example one now. And if I do this, it will walk me through a form because I didn't provide all of the information it needs to get started, like the directory that it should create the subgraph in locally. Once you fill all of those in, it will clone the subgraph, it will prepare, it will put your subgraph name in place and create a local project. And it will then install the dependencies, and it will also run Graph CodeGen or Yarn CodeGen in that subgraph so that you're ready to deploy right away. That will depends on the network. Can take a few seconds.
One thing I think we maybe skipped over is before you get started, you just need to install the Graph CLI global.
Yes, that's correct. Yeah. So to do that, you do npm install -g add graph protocol /graph CLI. Whenever you want to upgrade your Graph CLI, also run the same command. It will pull in the latest version. There's a chat message, but I can't see the chat window. Yaniv, can you check?
Yeah, I posted the Quickstart documentation with a lot of these bootstrapping steps listed inside of it.
Yeah, correct. So it will point you to the documentation at the end, but before you even have run this for the first time, it's probably worth checking out the docs. And there's a quick start guide for local development and for the hosted service. In this case, we're kind of doing the hosted service quick start, where you install Graph CLI and then you run graph init.
Yeah, so if you're building a subgraph for a contract that's already deployed somewhere, either on mainnet or on one of the test nets, then you might as well just go straight to the hosted service section, and you really don't need to run anything locally. But if you're actively developing your smart contract, that's when it makes sense to kind of set yourself up for local development. So as you make changes to your smart contract locally, you can reindex.
Yes, and there's a Docker environment that you can use, a Docker Compose environment that you can use. You can combine that with local Ganache and Truffle, and then you're all set to develop locally. So we have the example subgraph here, and I'll show you a bit of what's in here. The entry point is kind of the subgraph YAML manifest, which so first of all, this is like any npm project which has a package JSON with dependencies and so on. But then the starting point for the subgraph is the manifest, and it comes with a few description fields, metadata fields, like the description, the repository that you can provide as hints for people who view your subgraph in the Explorer. Then you will define a subgraph schema that defines the data model of your subgraph with all the types and their relationships and the fields and the types of those fields. That's basically the types of data that you generate from your smart contracts. And then for any smart contract that you have, you define a data source with a type. This is the only type that's currently supported. You'll give it a name, the name of your contract, the name of your project, the network that this will run on, which can be mainnet, Rinkeby, Kovan, Robson, the contract address, and the name of the ABI that you want to use, and the APIs are all listed under the mapping. In this case, there's only one, and then the mapping is what you define to specify which events or calls or blocks you're interested in handling or processing, and with what functions in assembly script in your mapping, and that's basically defining all the processing logic and trigger logic. So if we skip over these first fields, you'll list the APIs that you want to use. You can use multiple APIs for different contracts that are involved in your project that you have access to through, by virtue of having the addresses. And then you define event handlers, call handlers, block handlers. And each of those typically has like the event signature that you want to trigger on, or the function signature in the case of calls, and then the handler, which is a function that is defined in the mapping. And the mapping itself is written in assembly script, which is a subset of TypeScript that compiles to WebAssembly. So all of this gets run in WebAssembly at the end.
And for those of you that are new to Ethereum, there might be a few. The APIs are an output artifact of compiling your Ethereum smart contracts. So if you've got the contracts locally and you compile them, then you'll find these JSON files that describe basically like all the variable and function names. Right? That's what the APIs are. And then if you've got a contract that you're building a subgraph for that's already deployed, then most likely, if it's a well-known contract, you can go to Etherscan, and generally they'll have like verified source and APIs uploaded there, and so you can grab the APIs from there.
Yes, and if we have time, I'll quickly show that too.
Mm-hmm.
So this is the subgraph manifest, kind of bundles everything together. And if we take a quick look at the schema that defines the subgraph data model, it's Graph Cli SDL document where you define types with an entity, what's it called, directive, and you give each type a name, and then you can specify the fields for these types. There's relationships are supported, as well as string fields, bytes fields, big integers, big decimals for large decimal numbers, and a couple of other things. In this case, we only have one type. And then the other important part is the mapping that does performs the actual transformation from events or calls to this data model. In this case, we're listening to two events, new gravatar and updated gravatar. They are fairly similar. So both of them, I should probably open this. Hold on, give me 1 sec. Open this in VS Code. So we import both events from the generated code that Graph CodeGen or Yarn CodeGen generates for you based on the APIs and the schema. It's quite handy because that allows you to write type-safe code in here with all the types that correspond to your contracts, your structs and solidity, your data types in the schema, and all that is typed all the way through. In this case, we have two handler functions for the new gravatar and the updated gravatar events. And you can then use the imported events as the parameters. And then what you get is, if you have VS Code, it hopefully works in Atom too, you get auto-completion for everything that's available through that event. In this case, the contract address, the block that the event is part of, the index of the event in the block, the transaction that the event was emitted in, and also the parameters. And that's quite nice because usually events have named parameters, and then you can access them by their names. They have the right types. Owner is an address, for instance, and you can then use those values to set fields on your entities in the data model. In this case, we have the gravatar entity type, and we instantiate that, give it an ID, which in this case is an ID that comes from the event parameters, the ID of this gravatar. And then we more or less just copy the values from the event over to this gravatar entity. And you have, on the entity, you have both getters to get the different fields if they are already set, and also to set them like this with just an assignment. And that makes sure that if you try to do something that's not compatible, let's say owner to event params display name. So there's an address and string that doesn't work, and you get type safety here and warnings about this and compilation errors. And in the end, when you want to save an entity back to the store, you just do entity, well, in this case, gravatar.save, and that will write it to the database, and then you can query it. You can also load entities from the store by ID. If you know an entity already exists because a previous event will have created it, you can fetch it, and you can also lazily create them if you're not sure whether that was created before, and then you can work with those entities in the same way. So that's the mappings.
Yeah, should we maybe open it up if there are any questions about how to write these mappings?
Absolutely.
Just confirming that, so the recommendation is to add additional key values after instantiating the types in general?
You mean instead of just creating the types, that you also want to set fields on them?
Yeah, like you have a minimal constructor for new gravatar there, and then you decorate it later. That's the pattern you recommend? That's
the pattern we recommend. Yeah. Unfortunately, AssemblyScript, because it compiles to WebAssembly and has some limitations at this point, you can't use JavaScript objects with random key value pairs on them. So you have to you have to use types, and these setup properties are the only real way to populate these data, these entities.
Yeah, it's maybe worth just mentioning that we decided to use WASM as the VM because we really see this becoming a standard in the blockchain space. Right, it's very fast. You can make it deterministic. There are efforts like eWASM and in Polkadot to make it metered with gas. So we thought that was the right choice for the VM. And we thought that AssemblyScript was the easiest language for compiling to WASM, since most people know TypeScript. It makes it pretty easy to get started. But that said, it is like quite a young kind of language, AssemblyScript. And, it's like a two-person team. And we were actually, I think the first major project to actually use it and get it into production. And now there's a few other projects that are also using it. So, for example, Near is another blockchain protocol that is working on scalability and UX, and they're also using AssemblyScript. And so the hope is, I also know eWASM plans to support AssemblyScript. So we think as more projects kind of adopt this, since more people are using WASM, hopefully just the language will become more full featured. And so you are likely going to run into maybe some weird quirks while building these mappings, wondering, hey, why can't I do this JavaScript thing or that JavaScript thing? And it's just the reality that if we want to be using WASM and we want to have this nice language, we're going to have to deal with a few of the quirks until it matures. But it really should be able to do whatever you need it to do. And we've been actually quite happy with the fact that you can, even though sometimes you have to squint a little bit, you can basically do everything you need to do with it.
Maybe worth mentioning is if you go to the docs, then you can see there's also a section about the AssemblyScript API, which covers the different functionality, different features that we support, different types that we've built in, like Begin, for instance, or the IPFS API. Catch-Act 256 is available. Also, JSON parsing is available, and you can import these classes from Graph Protocol GraphTS. So similar to the Graph CLI package name, you can import for instance, begin, if you want to instantiate a begin from just, let's say, a number, like a regular int, you can do begin dot from I32, which is a more native WebAssembly integer type. You can then, let's say 15, and then you have a begin that you can assign to an entity, and you can also do like math operations with other begins and so on. Yeah, so it's worth checking out that API documentation.
Yeah, the biggest constraint with assembly script versus TypeScript is that because it compiles to WASM, which is a very like strictly typed runtime, you can't have any ambiguity whatsoever about the types. Every single thing needs to be like a well-known type. Okay, so we've got a few questions in the chat. So David is asking if we can aggregate data about events in the mappings. Yes, absolutely. So Jannis showed how you can do a store.load, for example, to like get a value that was previously set, or it's, I guess, an entity.load. And so that way you can get some value that was previously set, alter it, right? So that's kind of what you would be doing as an aggregation, update that value and then set it again.
Yeah, simple example could be an entity, gravatar counter that you could instantiate and then load again in any other event, and then increment the counter whenever a new gravatar is created or updated or whatever.
Not sure what the second question is about if you can use TypeScript natively to write a value. You can use this assembly script to do any kind of arbitrary scripting. So I believe the answer is yes. You're asking if we can compare the current event with the last event. So there's no native capability to get historical events, but what you can do is, if that's important to you, you can store the events as their own entity. So you could have like an entity event, and then each in the handler, each time it's triggered, you can just store that event, and then you can do what we just described to load the previous event, for example, and then compare it to the current event.
Yeah, could give every event a number as the ID, or a string representing a number that you increment with every incoming event, and that way you could know what the idea of the previous event was, and then you can load that up and compare them, for instance.
Yes. Ola asked if there are examples using 2 GraphQL clients in one React app. I think we did have something like this. I can't think of one off the top of my head, but if you post in the Discord after this, we could help out if you're having any issues with that.
2 GraphQL clients.
Yeah, I'm not sure if you mean specifically that you want to be able to hit multiple endpoints, or if you want to be using different like types of clients, like an Apollo and a Relay or something. But certainly you could hit more than one GraphQL endpoint.
Yeah, there's different ways to do it, for sure.
Mm-hmm. Okay, so there's a lot to these mappings, but the general idea is in response to events, you can access the event data, transaction data, block data, do any arbitrary transformation and scripting, save off these new entities, and then those entities get indexed, and then you can query them. So this right here is an example of an event handler. Also, just yesterday, we rolled out a major new feature. We now support block triggers and call triggers. So in addition to just triggering off of events, you can also trigger anytime a smart contract call is made. So sometimes these are referred to as internal transactions. So this is a new type of trigger we support now, as well as block triggers.
Yes, and I'm highlighting that here. You'll find it in the docs under define a subgraph.
Mm-hmm.
There's one more question about assembly level being low-level language. How compatible was it with the mobile browser?
Well, so these handlers aren't meant to run in the browser in the first place. This gets compiled to WASM, and then it's run in by the graph node. So right now we're running these graph nodes on the hosted service, and then eventually anyone will be able to run one of these nodes when and connect them when we launch kind of the decentralized network. But generally, these are meant to be run, on a node somewhere. Okay, Jannis.
Okay, if that's for questions, then maybe we'll deploy this to the hosted service.
Sounds good.
Cool. I believe I've already got a gravity subgraph here, and if I deploy the same version, it will not do anything. So I'm gonna.
Do you want to do it on staging?
No. Yeah. I can do it here. What I'm gonna do is I'm just gonna add something to the IDs.
Yeah, this would be a good time to maybe explain what the subgraph IDs are.
The subgraph IDs or the entity IDs?
Subgraph IDs.
Okay, yeah, so when you deploy a subgraph, what happens is that it takes the manifest and all of these files that are referenced in the manifest, like the schema, the APIs, the mapping gets compiled to WebAssembly, and then all the files are being uploaded to IPFS, and these paths get replaced with the IPFS hashes. And then the subgraph YAML itself with all those hashes in is also uploaded to IPFS, and from that we get a single hash that represents the entire subgraph that we can run, and that's what you see in the hosted service under ID. So that is the IPFS hash of the entire subgraph, that if you have access to that IPFS node, you can just IPFS cat it and get all the information back again, all the files. And that's also how we load the subgraph after it's being deployed, is from IPFS. And you'll see that if I run yarn deploy. What we haven't done yet is yarn build. It's usually not something you need to do if you want to deploy, but it can be nice to just build or even like repeatedly build the subgraph. That will do the compilation step and all that, but it will not upload the subgraph to the hosted service. Now we want to deploy to the hosted service really, and I also have made a change to the mappings so that it adds just a string to the end of the IDs of those gravitas, and I see I introduced a bug there too, because that needs to always be the case. And then what we do is we do yarn deploy, and that's thanks to like graph init, that's pre-populated to deploy to the subgraph with the name that we gave it when we ran graph init on the hosted service. So you can see it calls out to api.graph.com, uses our IPFS node and our deployment endpoint.
Did you do the graph auth already, or talk about it?
Yes. Yeah, I did that at the very beginning.
Okay, great.
Yeah. And so you can see here it compiles the data source mapping to WebAssembly, updates the files, and eventually uploads all of them to IPFS. You get the individual hashes, so you can get to those as well. And then the result is the subgraph ID, this one, which ends with KMA. It's deployed to this URL, so you can click straight on that and see it in the hosted service. And you can also copy these endpoints into your apps and use them in, for instance, Apollo clients to make calls to the endpoint of your subgraph. So if we go back to the hosted service, because I had a previous version and the new one is just syncing, I now have a pending version that will ultimately replace, when it finishes syncing, ultimately replace the current version atomically. While it's still syncing, the other version stays the official version, and you can still query that. You can also query this one while it's syncing using a different URL. And yeah, once that's finished, it'll switch over. And you can see the logs, see that processing. I think it's currently scanning historic blocks, still hasn't gotten to any events yet. But that's, yeah. Let's finish this quickly. Oh, that's the current version. pending version.
Oh, so David just asked a question in the chat about submissions. So go ahead and create the subgraphs and deploy them as frequently as you can, really, during the length of the hackathon. And then we'll have a submission process later that the judges can use to know what to look at. But yeah, basically just feel free to use a hosted service, throughout the entire duration.
Yeah, so this subgraph, I think it's processed all the events that are relevant already. You can see all the entities end with X, so that's with the change that we just made. You can see the logs for which events were processed, like this one, for instance, where a gravatar was updated. And this keeps updating as new events, as you transact new events, as you transact new changes into your contract and events get emitted. You can see these being processed here. Also, if there's any errors while your subgraph syncs, maybe there's a bug in the subgraph, something's not working, you'll see errors in the logs as well, and you can filter by them. And then you can play with, use the playground to run queries against your subgraphs. Maybe you're only interested in like the image URLs, for instance. You can change those queries, and you can then, if you want, copy them straight into your app when you want to actually use them. Cool, so that's graph init from example. I could quickly...
Should we maybe talk through the auto-generated GraphQL API?
Yeah, we can, yeah, sure. So we only have one type here at the moment, but the general schema is that we generate is that you have for every type, entity type that you define, you have a collection and an individual query field. So you can query for a specific gravatar by ID, like 0x2x, and get its ID and its image URL and its name, for instance. And that gets returned like this. And you can also query all the gravatars, 100 at a time. That's the limitation here, but you can query up to 100, and you can also skip 100 or 200 or 1000, so you can paginate through the data. Also, what you get is with every type, you get fields, arguments for the query fields, like for filtering, for ordering, etc. For instance, we can order by, let's say, the image URL, or then let's say the display name, just query the display name. And now, okay, these are empty, that's why they come first, and then starts with A, and then follows with B, etc. So now all the results are ordered by name. You can also do filtering with the where keyword, or with the where argument. And here you have the option to filter by using equality filters, by checking whether the value of a field is in a list of potential values, whether it contains a certain substring, or whether it's greater or less than something else, if it's a big int or a big decimal. So these kinds of things you can do to narrow down the result set and query for specific results that you're interested in.
Mm-hmm. We have just a few questions here. So David is asking about JavaScript libraries. So we recommend React and Apollo. So Apollo is a client-side library that gets data from using GraphQL and then passes it into your React components. So that's our favorite way to do it. Relay is another library that integrates with React that uses GraphQL. And then if you prefer another UI framework besides React, most of the other ones like Vue also have GraphQL libraries. So I'm not sure what the best way is to do GraphQL with Vue, but I'm sure there is one. Then another question from Perfect around how the WebSocket subscriptions work. So specifically asking what kind of updates they get.
Yes, so the subscription API that we currently provide is a live query type subscription API. So if you have a query like this, it doesn't work in the playground yet, but in your app it will work. You can do a subscription, send it to the subscription endpoint, and this subscription result will, or you will receive an update with the new result for this query any time there is a potential change in your subgraph, or specifically in those two entity types.
Yeah,
So
unfortunately, we have a ticket tracking adding subscription support to the playground. But yeah, like Jannis said, you can just toss that into your app and it should work.
Yeah, and if you run a local graph node in the playground that we have there, which is a pretty stock graphical interface, there you can actually put subscription in there and you can see updates as you know, events get indexed and data gets changed.
Yeah, so I think we're probably getting towards the end of the scheduled time. Could Jorge or Shreyas post in the chat just a link? I guess it's on the CoinList build page. I think we've got a list there of the example subgraph ideas for different protocols that could be indexed. So just, you know, some guidance around the subgraphs for the hackathon are, you know, the goal here is really to make data available in a way that's useful to people that want to build applications on top. So for example, you know, Colony is a really complex protocol. They've been working on it for a long time for doing like governance on top of Ethereum. And you know, if you wanted to build an application on top that showed, you know, the status of the different proposals and all the different things that are being governed with these DAOs, you would want to have a nice full-featured GraphQL API that you could use for building that interface. And so, you know, with a lot of these financial protocols, you know, maybe there's some, you know, information that's being stored in the contract, but there's all kinds of interesting financial stats that could be calculated on top, and maybe people want to have easy access to those stats. So really, I would focus on, you know, what is a good schema that like has all of these fields that people might want to be able to query about some underlying protocol. And so a big portion is going to be kind of the schema design, coming up with like a nice full-featured schema that has all the data that people would want. Obviously, correctness is really important. We're going to be rolling out a feature in the middle of next week called saved queries. So one thing that you'll notice right here is that we kind of auto-generate the example query that shows up in the playground, and there's no way to change that. And so next week we're going to be rolling out saved queries where you can kind of update the query as a subgraph owner and then give it a name. And then there's going to be a drop down where people can kind of explore around to kind of see how your subgraph is meant to be consumed. So, you know, you can get some nice example queries. So definitely we'll post about that when that's out, and it would be nice if people, you know, created some nice saved queries, which would help people, you know, see how to use your subgraph. And then finally, I don't know if we've posted the official rules yet. I didn't see it go out, but we do have one requirement for the hackathon, which is that we would like there to be some kind of UI for your subgraph. So that'll make it easier for the judges rather than them just having to come here and explore the data directly. Just having any kind of visualization, whether it's putting the data into a table or you know, having cards, whatever is a nice way to just, you know, visualize and see the data in some kind of UI. That would be really great. So we posted the examples here. And let's see, we've got a question about Mongo Neo4j instead of IPFS. No. So one of the core, you know, ideas behind the graph, let me actually turn on my video, is that we want all of the data that comes off of the graph to be like deterministic and verifiable. And so we only support Web3 data sources. So right now that means Ethereum and IPFS. Right? And so the idea is, there's all of these queries that you might want to run for your applications, but like if you run a query as of a certain block, there should be one and only one right answer to that query. And if we can build a whole graph of data that basically has that constraint enforced, then we think that creates a much more stable foundation for software. And so that's a hard limitation. Now, internally, we use a database to do the indexing, but that database is basically an implementation detail. And it kind of shouldn't matter to the application developer what database is used under the hood. So we use Postgres, but we may actually change that over time. For example, when we launch the decentralized network, we're likely going to have a different database that we're using under the hood. But your subgraphs basically shouldn't know or care how that data is being stored and indexed. So IPFS, so it doesn't store any of the data right now. Yeah, we just, we internally use IPFS to store the subgraph, kind of metadata. So like the WASM binary and those files are stored on IPFS. Now, one thing that we didn't talk about is that we do support indexing from IPFS, but right now there's only one mode in which we support that, which is when you have an IPFS hash that's anchored on chain. So let's say that you've got a smart contract. This is a popular pattern where you don't want to store a lot of data in your smart contracts because that's expensive. And so maybe, in the case of like Origin, for example, they have these listings which have like a lot of data related to the listings. And so the listing data itself is stored on IPFS. And then you have an event in your smart contract that, for example, is update listing, create listing, and that event can just log the IPFS hash, and then your subgraph handler can basically trigger on the event, get the data off IPFS, transform it however you want, and then put it in the store. So that's how you can get data from IPFS for your subgraph. Okay, do we have any other questions as we prepare to wrap up here? Cool. Really looking forward to seeing what people build. We're already seeing a lot of subgraphs getting created kind of every day. There's some really cool things in the works. It would be really cool to see a lot of these example subgraphs that we kind of posted out by the end of the 2 weeks. If you see that somebody's working on a particular subgraph that you were thinking of doing and it looks like they're doing a good job, it could be a good idea to do one of the other ones. There's, a bunch of these are really cool. There's all of these financial ones like SED and DYDX. I think some people are already working on those. Some of these DAO ones are really cool, like Colony. We're working with the Aragon folks right now, which is why I didn't put them on the list. But obviously Aragon's a really cool protocol that we like a lot. I saw someone started a PPth one, which is sweet. So that's like a kind of social network like Twitter. Claros and Civil and Corey and all of these are really cool. I don't think anyone's working on those. So actually, the sooner you create a subgraph and start deploying it to the hosted service, and that'll kind of put out a signal where people can see, oh, someone's working on this, and that could kind of help. Because it's fine if 5 people do the same one, but definitely it would be cooler to get a lot more things done.
Yeah, and something that's interesting is if your subgraph ends up being for a protocol that doesn't have an existing subgraph yet and is robust, you might see that after the hackathon, other people start building on top of it. So it is, in some sense, like a contribution to the community as well.
Yeah, totally. And we've done quite a few hackathons, like these ETH Global events. And generally, people have like their ideas of contracts that they want to build for over the weekend. Usually, there's only so much that you can do in 2 days, especially if you're doing the contracts and everything else. And so, people do pull for the graph as a tool in their toolbox, but I feel like some of those subgraphs don't necessarily end up in something that people are going to continue using after the hackathon. Whereas with this one, you guys have a little bit longer, and you don't have to build the contracts from scratch if it's if there's already some existing contracts. And so yeah, it's very possible that the subgraphs that come out of this are ones that people will really want to use, and that's really exciting for us. So thank you everyone for hopping onto the live stream and the workshop. We'll be on Discord if you have any questions, and we'll try to be as responsive as we can. We want to be very helpful in helping people build these subgraphs.
Thanks, Yaniv, Jannis, and Jorge. If you've not joined the Discord already, please do join. This call is recorded, so if you have any questions at any point in time, feel free to check back the video and then ask questions on Discord, and Yaniv and team will be happy to help you guys out.
Okay, thank you so much.
Thanks, everyone. Bye-bye.
Bye.